Welcome, my name is Brian Nelson. This is the 7th lesson in the Introduction to Programming with C# course. In this lesson, we're going to introduce the static modifier and take a look at how it is used with classes. Let's get started. The static modifier can be applied to either an entire class or it can be applied to methods in a class. If the static modifier is applied to the class, then the class cannot be instantiated as a variable. It can still have a constructor, but the constructor will be called when the class is first referenced rather than when the class is instantiated. The static class becomes a globally accessible object. We will discuss the concept of scoping and global variables in the next lesson. If a class is defined as static, then all methods in the class must also be defined as static. Let's take a look at setting up a static class in Visual Studio. In Lesson 7, we're going to be talking about static classes, and I'm going to create a new console app for Lesson 7. Lesson 7. I'm going to recreate what we were working on in Lesson 6. We'll clean up this. The way I like to create my code is I like to group things into folders. So I'm going to create objects, and then I'm going to create a folder, add new folder for helpers. I'm going to go ahead and recreate my temperature reading class, and I'm going to make it public, and I'm going to say public double temperature, and it's going to have a getter and setter, and public int hour of day. All right, so just do this real quick. Public temperature reading, going to create a default constructor. And now we're going to create temperature reading, int hour of day. Oops. Okay. And double temperature. Oops. You'll notice the way I make my variables here. This is with the lower first character, but upper first character of the next word. This would be lower camel case. This is upper camel case. So my properties I name with an upper camel case syntax, and the variables are lower camel case. I'm going to say now hour of day equals the parameter version, and the property I'm going to set to the parameter that's passed in. Let's rename this in Celsius. Just so there's no confusion. And that's one danger in these objects. What is the units of measure of your variables? It's very dangerous if you're doing certain types of things. What we're going to do now is we're going to create a static class, and it's going to be a helper. It's going to be temperature helper is what I'm going to call it. It's going to be public static. Let's go back over to our program. One challenge of putting things into folders is you need to have a using statement to tell the compiler where the class you're trying to reach is. So we're going to say using lesson 7.helpers. We're telling the compiler you can find code that this program is going to need in these folders. You can see the temperature helper and the temperature reading show up in my IntelliSense. So if we try to create an instance of this, t equals new temperature helper, it's unhappy. And what it's telling us is you cannot declare a variable of static type temperature helper. Static classes, there's only one instance of them, and it's created automatically by the compiler when you use them. You cannot create one on your own. So like if we were to say now temperature reading, and we call that TR, because the temperature reading is not static, we can create an instance of it. If we go back here, we could create a constructor for it that will get called, and we'll put a breakpoint in here. And when we go and start running this program, we'll see when that gets hit. But for now, we'll leave it here. Methods can also be made as static, even when the class is not. This means that the method is available without the class being instantiated. A side effect of this is that the static method cannot interact with an instance of that class. Let's take a look at how we can add a static method to a non-static class. I've got lesson 7 here, and I'm going to put that on the left. And then I've got lesson 6 here on the right. And so I'm going to copy the 2 Celsius and 2 Fahrenheit functions, and I'm going to push them into there. We're going to minimize this, and we'll go back to lesson 7. I put them in the wrong place. Let me cut them and paste it there. There. All methods or functions in a static class must be also static. What we have to do is define that as public static. Public static. Okay. We have a helper library with a 2 Celsius and a 2 Fahrenheit function. And so how can we use those? Well, I don't really know Celsius temperatures. It's hard for me to create a temperature reading object. I can do that easily in Fahrenheit. So what we're going to do here is say temperature helper dot 2 Celsius, and I'm going to pass in 32 degrees Fahrenheit. Okay, great. Oops. And then I can create temperature reading 2. We'll copy that, and we can pass in 70 degrees. And then we create another one, temperature reading 3, and we can pass in 90 degrees. We'll change the hours. What the static methods let us do is having a simple syntax. I didn't have to create a new instance of this. I'm able to call this function to do a conversion easily. I'm going to put a breakpoint here, and we're going to hit F5. Okay, and we're going to step over that. So what you see is when I went to use that first time, that constructor got called. And we're going to hit F10, so we'll finish up this function. So the second time we use that, the constructor didn't get called. So that static constructor and the temperature helper will get called the first time this static class is referenced. There we go. We've got the 3 different, we'll look at them down here. We've got the 3 different objects with their specific properties. The temperature reading is in Celsius, but say I want to write that out to the console. So console.write line, and we can then use temperature helper again, and we're now going to go to 2 Fahrenheit. And what we're going to do is we're going to pass in tr3.temperature. So what we're looking at is we're going to output to the console the temperature back in Fahrenheit. I'm going to move my breakpoint, hit F5. I still have a breakpoint here. We don't need that anymore. So F5 to continue. We've got 32 degrees Celsius, but when we go to write it out, if we look at our console, we get the 90 degrees Fahrenheit that we originally called. An additional way to utilize Static Modifier is to use it to create extension methods. Extension methods are useful to add functionality to a class without changing its definition directly. They can make the programming more concise. This is often useful if you wish to add functionality to a class that is defined in .NET without having to change the .NET code itself. An extension method is a static method that is defined in a static class. They utilize the keyword this to indicate that the method uses a specific instance of a class. I realize this sounds confusing, so let's take a look at setting up an extension method in Visual Studio to make this easier to understand. Now let's talk extension methods. Extension methods can only be defined in a static class. Let's create a public static double 2 Fahrenheit. An extension method extends a class without adding a property or method to the actual definition of a class. It lets us do that kind of virtually. The keyword is this. That says this is an extension method. We're going to make the extension method for temperature reading. And you'll notice it doesn't show up in my IntelliSense because I need to say I'm using lesson7.objects. What we're adding is a reference to this folder in our using statement. So now it's happy, temperature. We are extending temperature reading, and we're going to add a toFahrenheit method. And now we're going to use our toFahrenheit function up here. So we say temperature helper dot toFahrenheit, and now we're going to say temperature dot temperature. So what we've got here, this refers to the variable that's passed into this method, and this is the property. Now, why is it red? We need to return that. So if we go back to our program, in the old way we had this written is we had to call the helper right here. What we can do now is we can use the extension method, so we can say tr3 dot toFahrenheit. The extension method makes this much cleaner. We don't need the temperature helper dot toFahrenheit paren pass in the object dot temperature. By using the extension method, we can very much clean up our code. I find them very, very helpful to clean up your code and to make it organized. Because I can control click and jump into that method, I can see very quickly it is an extension method. So I'm not confused. I can use my tools to find where that code is. You'll notice that, that same tr.toFahrenheit is available on all of the classes. So it's not limited to just one of them. You can use it on any of them. We're going to put a breakpoint. We're going to run to the end and I can hit F5 or run. Go back here. We can see 90 is output as well. We can also do static void. We're not going to return anything, and we're going to say from Fahrenheit. And now we're going to pass in a double temperature in. It's not red because we're not returning anything. So you can pass in different parameters in addition to the object that you're extending. And so now we can say temperature.temperature equals, and we're now going to use the toCelsius function up above. And we're passing in the temperature in Fahrenheit. So this parameter gets passed in. We call the toCelsius function that takes us up to here, and then we run this code block. So now we can say tr3.from Fahrenheit. We don't have to supply the first parameter, we just have to supply the temperature of 85 degrees. Let's copy this. Okay, so now we're going to set line 17 here. We'll set the temperature to 85 Fahrenheit. That will get converted into a Celsius that's stored internally. And then at the very end, we're going to output it again. So we should get 90 and then 85 in our output when we run. So I'm going to hit F5. Now we're at the from Fahrenheit function. F11 steps into this function. So we can see that 85 was passed in. Our object was passed in. I'm going to step over this. 85 converts to 29.4 Celsius. So now we have TR3 with that hour 2 and 29.4. If we look, we do have the 90. So we're going to hit F10 to step over this. And we can see the 85 came out. Just so you're aware, we can get rid of these as well. Because we're in this static class, we don't have to refer to those with the class name. And you can notice, we'll just run to the end, F5, and it still functions 90 and 85. When you're in a class, you can ignore the class name dot that you're trying to reach. You can use it or not. So you can do it either way, and they'll both do the same thing. This wraps up the 7th lesson. The next lesson, we'll look at scoping and access modifiers and how they can be applied to a class.